Skin tone plays a large role in how we experience and are treated in the world, and even factors into how we interact with technology. There are countless examples of where the industry has fallen short and where products have not worked well for many skin tones. This is why the Google Skin Tone team was created, to help Google build products that work well for every person of every skin tone in accordance with our AI principles. Our team consists of UXRs, colorism experts, research scientists, and engineers who all leverage their expertise to help minimize skin tone inequity for ML products. At Google, we use ML fairness evaluations to help understand the common human biases that can manifest in our ML algorithms and ultimately our products. Over the last few years, we've been working with Dr. Monk to validate the Monk Skin Tone Scale, frequently known as the MST Scale, for use in ML fairness efforts, and we shared it with the world last year on skintone.google. Teams within Google are using the MST Scale for ML labeling tasks, ethnographic research, and fairness testing. And now we'll teach you the guiding principles of using MST for your computer vision fairness workflow, based on what we've learned over the last few years. For today's talk, we've broken it down into 4 do's and 1 don't. Our recommended things you should do are practice inclusive product development and testing, annotate your data responsively for skin tone, use MST images, and follow Google's AI principles. As for our don'ts, we really implore practitioners to refrain from trying to correlate race and skin tone in computer vision efforts, aka don't equate skin tone to race. Let's dive deeper into each of these points. So when you're building products, make sure you practice inclusive product development and testing. Particularly, you want to build inclusive datasets. This means making sure training, evaluation, and dogfooding datasets include representation across the entire MST scale to account for a diverse range of people and tones. Secondly, you want to run inclusive evals. This means you should evaluate your algorithm and products on data that includes as many tones on the MST scale as possible. And thirdly, you should consider intersectional slicing. Let's talk through a theoretical example of building an inclusive dataset. Let's say we have this data that will be used to train an ML model. When we build inclusive products, we want to ensure that no matter the skin tone of the person in the image frame, the model still works the same way. This means for training data, we should be checking that the training data has a similar number of images per skin tone category and is essentially a balanced training dataset on skin tone. Now let's talk evals. Let's say we want to use a model that our coworker built for our product. When we're testing this model, we want to ensure, once again, that no matter the skin tone of the person in the image frame, the model still performs in a similar manner. In practice, this looks like making sure the metrics that are important to your product perform similarly for different skin tone buckets. As you see here, we have an accuracy versus skin tone theoretical eval example. For a case here, we would be looking to see that the accuracy is above something like 90%, no matter the skin tone bucket for all the data we tested the model on. Now let's talk intersectional slicing. At Google, when we build a product, we want to build for real people. And real people are complex and have many attributes. Take me, for instance. My skin tone, my hairstyle, my perceived age, and gender expression are all signals you as a human are taking in to process my existence. Intersectional slicing allows you to combine skin tone with other features to identify subgroups that are important for evaluating fairness and ensuring no matter the subgroup you're testing on, once again, that your model ultimately and the product performs well. In practice, this looks like testing whether your model performs the same on, let's say, a feminine presenting MST Scale 8 with sunglasses on, and a feminine presenting MST Scale 8 with sunglasses off in the same manner. Intersectional slicing is one way to measure how well products are being built for and performing on real people. Our next tip to practitioners is to try and annotate your data responsively for skin tone. A person's skin tone is not a single color across their body or even an RGB value, but a range of shades across a complex surface. In order to capture this nuance, we recommend using all the tones of the MST scale. Don't group points into categories like light, medium, and dark, as that will hide some of the important nuances. Furthermore, in our research, we found that shared regional cultural context and lived experiences impact a person's mental model of skin tone. For this example, we see here that on this given image, annotators in India have a significantly different view of this person's skin tone versus annotators from the US. However, when we annotate skin tone with a diverse set of raters, these regional differences typically average out to the true underlying skin tone of the person, within one tone of ground truth. In addition, we found that 2 raters per region reduces the variation in global consensus. Given this, we suggest enlisting a geographically diverse set of annotators within one region and at least getting 2 raters per region. Lastly, we urge practitioners to take lighting into account when rating data on skin tone, as lighting plays an important role in perception. Find this research and more on skintone.google. In order to help practitioners annotate their data responsibly along skin tone, we've worked with an external organization to curate a golden set of sorts that you can find on skintone.google. The primary goal of this dataset is to teach you how to rate on the Monk skin tone scale with exemplars, and to help you teach your annotators to annotate skin tone consistently on the fine-grained Monk skin tone scale. We encourage you to use this resource. And once again, you can check out this golden set on skintone.google. Google has a series of guiding principles that we assess our AI applications with. The core of these principles is to ensure we create technologies that solve important problems and help people in their daily lives. And we encourage you as practitioners to do the same. Pause the screen here to take a look at these in detail and check out ai.google for more information. Lastly, we implore you to be wary of equating race to skin tone in your ML fairness efforts. In developing this scale, one of Dr. Monk's intentions was to help decouple skin tone and race, 2 concepts that are often conflated. Racial and ethnic groups can include people from a vast spectrum of skin tones, not just one skin tone in real life. So we want to ensure that our models account for these differences, both within and between ethnic groups. This will allow us, as an ML community, to move towards more nuanced and inclusive technologies. Thank you for listening and working to make computer vision more inclusive. Give feedback on skintone.google.